All right, welcome to part 2 of the bullet penetration tutorial. So I'm just going to start right where we left off. So let's go back here to our first person character where we're doing our line trace. And basically what we want to do is um, we want to figure out what we hit. And then the very first thing we want to do is we want to draw that little bullet hole on the thing that we hit so that we can see that we've hit it. And we want to do that first because we're going to do that regardless of if the bullet penetrates the object or not. We still want to draw the bullet hole on it, right? So let's just drag off of this return value and do a branch. So this is just checking, hey, did it actually hit something? So if it did, then we want to spawn the bullet hole. And I'm actually going to make a little function for this. I'm going to make a little function library that kind of helps us out with some functions that we're going to need here. So let's go back to the content folder and over here. And it doesn't really matter where you add this, just right click and say blueprints and blueprint function library. And if you don't know what a blueprint function library is, it's just basically a library of functions that you can call from anywhere. And it's just kind of a nice little way to add sort of generic functions to wherever you want. Maybe there's a better place to add these in your code, but for the sake of this tutorial, I'm just going to add them here. So we'll just call this the tutorial library. Open this up. So we want to add a function in here. We're going to be adding more later, but for right now, we're just going to add this one called spawn bullet hole. And what a bullet hole basically is just a decal. I don't know if any of you have worked with decals before, but they're basically just textures that you apply to surfaces at runtime. Or it doesn't have to be at runtime, but they're used for bullet holes and like blood splatters and stuff like that in games. And so to do that, you need a texture that you want to use for the decal. So if you look in the description of this video, there will be a link to a download for the texture that I'm using. It should look something like this. The folder, it should just be a folder and it just be this t_bullet hole PNG in there. So what we want to do is come back here to our content folder again, and then take this texture and drag it into your scene. And if you double click on it, you can see what it looks like. It's just a little bullet hole. And so in order to use this for a decal, we need to set up a material with it. So if we right click and say create material, and we'll call this m_bullet hole decal. And there's a couple little things we need to change in here in order to use it as a decal. So if you double click on this to open it up, the main thing you need to change in order to use this for a decal is you need to change the material domain to be deferred decal. And then you need to change, you can see it'll give you an error down here. It says, hey, the blend mode needs to be set to translucent. So set the blend mode to translucent. And then one other thing we want to change here is the Decal Blend mode. We don't want this to be translucent because we don't actually want this to be transparent. We just want it to be whatever color it is. So let's just set this to debuffer translucent color. And then we want to change this so that this goes to the emissive color and this A goes to the opacity. And then we can hit apply and save. And I'll just kind of show you guys what this looks like if we were to drag it into the scene. So if you don't know already, you can just over here on the left, you can search for decals just to kind of preview it and drag a decal into the scene. So this kind of ugly green texture is the default decal texture that it uses if there isn't one. But you can come over here on the right and assign your own. So I'm going to search for the m_bullet hole decal that we created. And there you go. There's our bullet hole. Obviously, it's a bit too big, but that's the material that we created. So one thing to know about decals is that the rotation of them matters. So if you try to drag this over here on this wall, you can see it doesn't look that good, and that's because it's not rotated correctly. So you need to rotate it like so, 90 degrees, and then it will look, correct. And it's obviously dependent on the size. So if you scale it down, then it will scale down the size of the decal. And another thing worth noting, because we're going to have to fix this later, is that decals show on both sides of objects. So you can see it shows here and it shows here. And you might be thinking, oh, that's good because we want to show the bullet hole in the back, but we actually don't. We actually don't want this behavior because if you think about it, if you fire from like up here at an angle and you shoot down, The bullet hole in the back is not going to be like anywhere near the bullet hole in the front because it's going to travel down through the inside of the mesh and then come out, towards the bottom of it. So if the bullet hole was exactly on the same side but on the back, then it wouldn't line up because that's not where the bullet actually came out. So in order to fix this, you really just need to make sure that the size of the decal is smaller than the width of the thing that you're um, having it on top of. So I'm just going to come down here and use this because it's a little bit easier. So if you set this to 1 and like 10 and 10, and then you move this out, let's see if I can get it lined up. Like so. Then you can see now it shows on the front. Sorry, my camera's like way too fast. So now it shows on the front, but if you come around to the back, it doesn't because it doesn't reach around to the back. So that's basically what we're going to be doing in code. We're going to spawn in one of these and setting the size up and the rotation to look like this. So I'm just going to delete that for now. I just kind of wanted to show you guys how that worked. Let me turn my camera back up. Okay, so back in our tutorial library, we have our spawn bullet hole. So inside of here, we want to, where is my reference code? Hold on. Yeah, inside of here, we want this to take in a hit result. And the reason we want it to take a hit result is because back here in our first person character, we just want to pass this hit result to our spawn bullet hole function and just have the bullet hole function figure out, where it should spawn. We just want to keep it simple. So over here, we're going to take in a hit result. So we'll just say hit and make it of type hit result and compile. And so if you right click on this and you can say split the struct pin, then it will split it just so we have access to everything inside of here. And we want to spawn our decal. So we'll say spawn decal. And you see there's two options here. There's one for location and there's one for attached. Now for my tutorial, I'm going to use attached because if you actually attach it to the object, then if the wall moves or something, then the decal will follow it, which is obviously a good thing. But if you know your walls aren't ever going to move, the ones that you're hitting, it might be better potentially to set this to location because it's probably a little bit more optimal. But I'm just going to use attached just because it works in more situations. So the decal size, if you remember from before, I used 1, 10, 10, and that makes sure that it's the correct size and that it also doesn't go through the back side of the wall. If you have really skinny walls, you might have to set this to something even smaller, like 0.1, but in most cases 1 will be fine. And then attached to component, we want it to be the hit component. Oh, and the decal material obviously is our m underscore bullet hole decal. The location is going to be our result location, or our hit location rather. I think you can use impact point as well. I don't think it actually matters. I think they're the same thing in this case. And the rotation needs to be the normal of the surface that we hit. So we want to take the impact normal and say make a rotation from x vector, And obviously what that does is it takes the x vector, which is the forward vector, which is the normal, and it makes a rotation out of it. And we say use that as a rotation. And then finally we want to change this to be keep world position so that it uses the world position. And then one little other thing here that I did in my tutorial is you can set the, well, I'll show you the problem before I fix it, and so you'll understand why. So let's come back here to the first person character. And so now we have this little spawn projectile or spawn bullet hole function. So we'll say spawn bullet hole, and we'll hook this up to true. And then since we have it taken in a hit result, all we need to do is just drag this guy over here. And I'm just going to double click and make some little reroute nodes here just to make it a little bit cleaner. So now we can see this hopefully working if I did everything correct. So if we hit play, come over here and we shoot this, you can see it spawns our bullet hole. And the bug that I was mentioning before, well, not really a bug, but the thing I was mentioning before is, so you can see if you back up, it actually fades away a lot sooner than I would like it to, at least, because you can actually like see it fade away pretty easily. And you can fix that real easily by coming in here and dragging off the return and saying set fade screen size. And by default, it's set to 0.01. So that's saying once it gets to take up 0.01% of the screen size, then start fading it away. So you just need to lower that value if you don't want this. So it says like 0.001, and then it won't fade out till you get further away. And then another thing worth mentioning for the decals is the lifespan. So if you leave this at 0, then they're just going to be there forever, which is probably not a good idea because usually things like bullet holes fade away over time, mostly for performance reasons. So you can set this to like 10 seconds. And there's also options in here, if anybody's curious, for like fading. So it doesn't just delete outright, it just kind of fades away when you delete it. But I'm not going to go into that too much because you guys can figure that out pretty easily, I think. So there we go. So now let's try it again. Come over here, we shoot the wall. See if we move away from it, we can still see it. And then after 10 seconds, it should delete itself. There we go. So that's working pretty nicely. So now we got our bullet holes showing up so we can see where it's hitting. And so we can go back to our first person character now and keep writing this. So again, just to recap, all we've done so far is we just played the animation, we played the sound, we told it to ignore the player, we've calculated our start and end so that it fires, from the camera into the world, and then we did a line trace, and if it hits something, then we draw the little bullet hole on whatever we hit. So now what we want to do is check if the bullet should go through this object. So to do this, I'm actually going to create a little, how do I even do that from here? I don't think I can. We'll just start writing the code and then we'll collapse later. So to figure out what we hit, or figure out if it should go through it, we need to get the surface type from the thing that we hit. So let's drag the off of this guy and say split or break. Yeah, sorry, I did that really quick, but it's just break hit result. And then hit this little drop down here so we can get access to everything. So the material we're going to get access to from the physics material. So we can drag this and say get surface type. And then from there we can say, from there we can see what surface it hits. So for now, just to kind of show you guys, let's just do a little print string here and then hook this up and hook this up just to quickly show you kind of what's going on here. So when I hit this guy, you can see at the top left, it prints out brick. When I hit this guy, it prints out wood. If I hit this guy, it prints out drywall. If I hit like the ground or something, it's just going to print out default because it doesn't have one assigned to it. So you can see it's detecting the type of surface that we're hitting. So yeah, we're talking about the surface type. So we want to go and figure out a way to affect the bullets differently depending on their surface type. So to do that, let's go back to our tutorial library here, and we're going to make a new function that's going to help us out with that. So up here we'll hit function, and we'll call it get surface density. So what this function is going to do is it's going to take in a surface type, and it's going to return a density value from 1 to 0. So if it's 1, that's going to mean that it's like completely dense and that nothing can go through it. If it's 0.5, then it means it's kind of dense. And so basically the math is just going to work out where, if you remember, we have this bullet strength thing here. So every time it passes through a wall, the density is going to be subtracted from the bullet strength. So if the density is 0.1, then it's going to be able to go through 10 walls, for example. So where were we? So back over here, like I said, we want it to take in the physical surface. So search for E physical surface, and we'll call this the surface. And then it's going to return a float value for the density. So output float, set it to density. And then off of the surface, we're just going to do a switch. Or I guess we can do a select. So we'll do a select instead, and then hook this up to the return value. And then here you can determine your values. So for default, which again, default is going to be what it's going to be set to for things in your world that you don't have a physics material assigned to. So for this, we want to set it to 1 to say bullets should not go through these objects. And then for drywall and wood and brick, or whatever ones you've set up in your game, you can set these to whatever you want. So the lower the value, the more times the bullet will be able to go through it. So for the drywall, I'm going to be like 0.15. The wood will make it a little higher, like 0.25, and the brick will be even more higher, like 0.5. So again, it's really simple math. It's just saying, so 0.5 for the brick means that it can go through one wall and then it will stop at the next one. The wood will go through 3 walls and then stop at the 4th one. The drywall can go through like 7 or whatever and then stop at the 8th one, and so on. So you can adjust these values however you want. All right, so now we have this little function set up. We can come back here. One thing we should do with this function is, since it's just so simple, let's select it over here and set it to pure, and it can be const as well, but it doesn't really matter. So now we can come back here to our first person, and then over here on the left, or on the right, instead of just printing this out, we want to delete this and call get surface density, and then sorry, I'm checking my notes again so I don't mess this up. Where was it? Oh yes, okay. So we want to take the surface density and we want to subtract that from our bullet's strength. So drag in our bullet strength, say get, and we want to do a float minus float, like so. And then we want to take this value and we want to clamp it between 0 and 1. So we'll say clamp float between 0 and 1. And then we want to set the bullet strength to whatever that is. And this is just assuring that it doesn't get below 0, basically. And then we can hook that up like so. And then finally from there, we want to do a check to see if this is still greater than 0. So we'll say float greater. And then we'll do a branch. And so what this is just checking is if the bullet strength is greater than 0, then it means the bullet should continue to pass through walls, basically. And so what I'm going to do, I'm going to take all of this just to kind of simplify this visually a little bit, and then right click and say collapse nodes, and bring us up here. And then I'm going to reorder these, so that's on top, and then rename this to the fizz mat. And then we'll call this like calculate bullet. We'll say bullet penetration. Calculate bullet penetration. So if we double click on this, you can see it's moved our code over. And then we want to hook the outputs up. So we'll hook this up to there and hook this up to there. For true, we're going to rename this to like go through wall. And then this one will be called stop in wall. So we can pile. Oh yeah, one little bug about Unreal is that whenever you move local variables into a collapsed node, you have to like re-add them. I don't know why. So for the bullet strength, just delete it and re-add it. And then do the same thing for the set. Hook this up. Hook this up. Okay, I guess Visual Studio just decided to open. We'll close that. Oh gosh, where are we? All right. I'll review this here in a second because I know I did this kind of fast and crazy things are happening. Okay, so again, just to recap, let's go back here. So this is what your code should look like. After the line trace, it does a branch and it calls spawn bullet hole. And then after spawn bullet hole, it calls our little collapsed node here called calculate bullet penetration. And then off of that, we'll have two options. It's either going to tell us to go through the wall, or it's going to tell us to stop and say, hey, you can no longer go through any more walls. And we want to hook up the physics material to the physics material. And then inside of here, inside of here, just pretty simple logic. Why is this not letting me drag this down? Okay. It takes the physics material, it checks which surface it is, which again is like our drywall, our wood, or our brick. And then it subtracts the bullet strength, or it subtracts the density from the bullet strength. And then it makes sure it doesn't get below 0. And then it sets that value. And then it just checks if it's greater than 0 to determine if it should continue or not. So hopefully that's pretty straightforward. All right, so now we can come back here. Now that we know whether or not we should continue past the wall or not, and we can make our decision from there. So if we want to stop on the wall, we actually don't really want to do anything. So you can maybe add a print here if you just want to see it get hit, or maybe you want to do something when it stops. Maybe you want to add like a smoke effect or whatever, but for us, we don't really need to do anything. We're just going to stop and get out of this function. But if it if it is telling us that it wants to continue to go through to the next wall, then we need to do a couple things. The first thing we need to do is, remember this ignore list that we have, which again, this keeps track of all the actors that we're currently ignoring with our line trace. We want to add the wall or the actor that we just hit to this ignore list so that we can't hit it again. So take our hit actor, or take this rather, and say add, and then drag in our hit actor to this, and hook this up to go through wall. And then I'm just going to make a little reroute node just to make it a little cleaner, like so. So that's the first thing we want to do. And then the next thing we want to do is kind of complicated. We want to calculate where the bullet should exit the wall at. Because if you remember from my tutorial at the beginning, so this is my other one real quick, you can see if I shoot through this wall, even if I'll use this one as an example. If I shoot through this wall at some weird angle, you can see it calculates that the bullet came out over here because that's the trajectory of the bullet, right? And to do that, what I'm doing is I'm actually doing a line trace in the opposite direction to figure out where the bullet would hit the wall if it was coming the other way, which obviously, makes it so that it appears that that's where it would come out if it went through the wall. So to do that, we're going to make a little handy function again in our tutorial library. So come back here to our tutorial library, and this is the last function we're going to need inside of here. So hit the function button, and we'll call this line trace exit location. And this needs to take in a few variables. So over on the right, we want to add a vector for the enter location. So this is where the bullet entered the wall at. We want to add another one for the direction. So this is the direction that the bullet is traveling in. And then we want to add one more for the actor. And so this is the actor that the bullet is traveling through, essentially. Okay, so from here, we want to, essentially, like I was saying before, we want to do a line trace in the opposite direction that the bullet's going in to figure out where it's going to come out of the wall at. So to do that, we need to go past the wall, like to the other side of the wall, and then start tracing back the other direction. And in order to figure out how far past the wall we can go, we need to get the actor's bounds to figure out the size of the actor. So we'll say get actor bounds. And I'm going to go ahead and check both of these boxes so that we're only using colliding components and we're also only including children actors. And then for the box extents, we want to take the max because we're going to get the max. Oh, sorry. We need to split this. So right click and split so that we get the X, Y, and Z. And then we'll drag out this and say max. And so what this is doing is it's finding us the max. We need to add one more pin. It's finding us the max, like which side of the box is the largest, and we're going to use that size. So that way we can always guarantee that we're past the end of the object. And then we want to take this value and multiply it by 4, and you might think that that's kind of an arbitrary number, but there's actually a good reason for it. So it's 4 because, well, we need to multiply it by 2 because these are half of the size since it's from the origin. And then another 2 just to guarantee that no matter what angle we shoot it at, if we multiply it by 2, it's always going to be greater than the extent of the box. So we're multiplying by 4. And you could do some like really fancy math here to figure out exactly where you need to start the line trace from so that you don't start too far and like potentially waste whatever, but the math would just be probably so complex that it's not even worth it. We'll just say it doesn't really matter if it starts like a couple feet beyond the end of it, like who cares, right? The important part is that we're sure that it's going to start like not inside of the wall, for example. So now we have this value. So this is going to be our trace distance. So let's right click and say promote to local variable. And we'll call this on the left here, we'll call it our trace distance. And we'll hook this up. So now that we have our trace distance, we want to do our line trace. So again, on the left, we want to create a few more variables like we did before. We'll call it our trace start. And we'll make this a vector. We'll duplicate that. We'll call this our trace end. And that should be good. So for our trace start, drag this in and say set. So we want to set this to be our enter location, which is a parameter that was passed in. So just right click and say get enter location. So we want our trace start to be the enter location plus the direction that the bullet's traveling in times the distance that it's gone. And if I'll just draw a quick little picture here to demonstrate. So if this is your wall and you're kind of looking at it from the side, and the bullet is traveling this way, you know, from the top left down to the bottom right, our enter location is going to be like here. And so we're saying, and we basically want to get, you know, this point, right? So we're saying that the line trace start, because what we're going to do is we're going to do another line trace, except we're going to line trace back this direction instead, from the bottom right to the top left. And so our start location for that line trace is going to be this location, which is our enter location, plus the direction that the bullet's traveling in, which is down this direction, times whatever trace distance we decide. So the trace distance is probably going to be a little bit longer than this box. So it's probably going to be like somewhere down here. So we're saying this is our start location, and then we're going to use that, and we're going to go back this direction and trace back up. And so, of course, it's going to hit right here. Hopefully that made sense. Okay, so we'll say vector plus vector, and then our direction will be this direction. So just right click and say get direction. And then I'm going to multiply that by our trace distance. So float times vector, and this will be our trace distance. And we'll hook that up like so. And that is our trace start. And then for our trace end, we want it to be our trace start plus the, well, yeah, so drag in the trace end, say set, and this is going to be our trace start, so vector plus, and our direction again, so we'll say get direction, and then float times, and we want this to be times our trace direction, or our negative trace direction, because we want it to go in the, our negative trace distance, because we want it to go in the opposite direction. So we'll drag in our trace distance, and we'll say float times -1. Hook that up, and we'll hook that up like so. And this is our trace end. All right, so now we have our trace start. Let me just double check that I did that correct. So we got our enter location, direction, trace distance, and that's our trace start. And then we got this direction times -1. Okay, that looks correct. So from here we can do our line trace. So drag off of this and say line trace by channel again. And again, this is the line trace in the opposite direction. So we're going to use our trace start and our trace end. And we need to have this ignore list set up again, because it's possible in this picture here, like it's technically possible that there could be another object right here. And obviously we don't want it to think that this is the exit location for this object over here. So we need to, if we hit an object and it's not the object that we're looking for, we need to add it to our ignore list and then start tracing again. So let's right click on this and say promote to local variable, and we'll call this our ignore list. And by default it's just going to be empty because obviously we haven't traced yet, but over here we're going to be adding to it here in a second. So we'll do our line trace, and we'll do a branch to see if we actually hit anything. Now, if we don't hit anything, we just want to return false and like basically nothing. So let's add an output pin. So click on the node over here on the left, and then on the right we can add outputs. So we want to output two things. We want to output a bool for whether or not we hit something. So we'll say hit. And then we also want to output the hit result. So another one, call it hit result, and we'll call it hit result. and then we can right click, or where did it create this thing? Yeah, it created over here. So drag this guy over. So again, if we didn't hit anything, then we just want to return our hit result, or our empty hit result, and we want to return false. But this should really never be the case because we should never not hit anything since we're going back in the direction of our object. So in most cases, well, in all cases really, it's going to come up here. So we want to do another branch, and we want to check if the thing that we hit is actually the object that we care about, or the actor that we care about. So we can drag over this and say break, and hit this drop down. And we want to check if this hit actor equals the actor that was passed in, because you remember, it passes us in an actor. So we want to check if they're equal. So we'll say, actually we're going to check if they're not equal, just because that's the way I'm going to do it. So if they're not equal, we need to right click and say get actor, get this guy. So if they're not equal, then we want to keep tracing, because remember, if they're not equal, then we want to restart the trace so that we can get back to the object we hit. But if they are equal, which is going to mean false here, then we want to go ahead and return it. So I'm just going to copy and paste this return node, and then our hit return is going to be this guy. So let me just kind of make this a little more organized. Something like this, good enough. So we're returning the hit result, and we want to check true to say, like, yes, we actually hit something. But if we didn't, then we want to actually go back and restart the line trace, but with a new trace start location. Because if you think about it, if we hit right here on this first orange X, we want to restart the trace, starting at this orange X and ignoring this black wall here on the right. So we want to update our trace start, so we'll drag in our trace start and say set, and we want to set it to our impact point. So we'll drag in our impact point like so. And then, like I said, we want to restart. So the location we want to restart to is back here right before the line trace. So if you, well, let's see. So I think we can double click right here to add a reroute node. And then if you take this and you drag back here and then hook it up, it will loop back around. Now it's kind of hard to see because the lines are on top of each other. So if we kind of move this down and then double click, we can move this out and kind of see what's going on here. And make another one here. And there it's starting to make more sense about what way the lines are going. So you can see it just loops back and it does the line trace again, and it updates the trace start first, so that it's not just gets stuck in an infinite loop, basically, right? Oh, and one thing we forgot to do, we need to add this actor to our ignore list, so we ignore it. So let's just kind of scooch this over a little bit. I'll scooch this guy over. Organization is very important in a time like this. I cannot stress it enough. Okay, so we just want to add to our ignore list. So we'll drag in our ignore list and say add. Hook this up, and we want to get this actor. So drag in the actor. I don't really like my lines going crazy, so I usually like to do something like that, just so you can kind of see better what's going on. There we go. So this is the end of this function, I think. I'll just go through it real quick to recap. So it takes in the enter location, which is where it entered the actor, and then the direction in which the bullet's traveling, and then the actor that it hit. And then we get the size of the actor to figure out how far we need to go past it in order to be completely past it. And we say that's going to be our trace distance. And then we start tracing from the trace distance past the object back towards the object. And then in our line trace, if we hit an actor, we check if the actor that we hit is the one that we actually care about. And if it's not, which is this true case, then we add that actor that we hit to our ignore list because we don't care about it. We don't want to hit it again, and we update our trace start to be the hit location of where that object is. And then we keep doing that over and over until finally we hit the object that we care about, which most of the time is going to be the first time, but every once in a while it won't. And then we return that object and the hit result, and we're good to go. So now we can come back here to our first person, this guy. And again, over here, we've decided that we want to go through this particular object. So we've added it to our nor list, and we want to call our line trace exit location to get the exit location. So the info location is going to be our impact point. So we'll take our impact point and drag it into our enter location, like so. The direction is going to be our trace direction, so we can just drag in our trace direction. And the actor that we hit is obviously our hit actor, so we can just drag this guy up here, like so. So let's go ahead and test this out real quick before we go any further. So what I'm going to do to test this is I'm going to take this draw debug time, is that it's a none, and then go inside of the line trace exit location and set this guy up to draw the debug line so we can see what it's doing. So if we run this and we hit this wall, we should see, there you see, so you see a line trace going from back here up to here. And the reason it's coming from all the way back here is because this object happens to be super tall and skinny. So to be safe, because it could be oriented any way, we're just going all the way back there. So you can see if I hit this one, it does it as well. And if I go through multiple objects, you can see it's hitting all these objects, but it's continuing. It's doing another line trace until it finally gets to this one. So it's detecting basically where the backside of this object is. So that seems to be working pretty well. So at this point, I think I'm going to go on to part 3 of this tutorial just because it's getting a little bit long. So I'll see you guys in part 3.